All right. Good morning. This week, you're not going to have any quiz, but you're going to review for the midterm exam. Okay, the midterm exam, I already sent you the information of the weekend. Is going to be from Friday. It's going to be online. Okay, so from Friday through Sunday. Okay, you have 3 attempts. 3 attempts. So each sitting, I haven't decided how much time I'll give you for each sitting. A minimum of 60 minutes, but I will give you, accurate time before Friday for sure. Okay, because right now I'm still preparing the questions for the midterm exam, and I tentatively is about 60 minutes. It's about 60 minutes, and from your part, 60 minutes. Let's see, 60 minutes. Tentatively. So it should be at least that much time. So you have 3 days, 3 sitting, and 2 all right, let's have an awesome day. Good. I'm glad you're. Does that mean you're excited for the class? I'm glad to see that. Well, the next thing, yes. Okay. As far as what's gonna be tested, primarily the material from the first 7 weeks. Okay. And this week, we are going to cover some materials. If any material that this week will be on the exam, I will let you know. And otherwise, we're just going to move forward. Okay. Will I do a review session for you? I think I will do a review session for you on Thursday. And meanwhile, I'll give you this time to review and to have your question ready and so on and so forth. All the quizzes, right? All the quizzes. I think there's one quiz number 16 for you guys. I opened it late, so it's due on Tuesday. But most of the other quizzes, they're ready for you to view. Thank you, Angelica. And they're ready for you to view for the answers and stuff. Okay, solutions are available until Thursday night. Okay, so be aware of that. So when you review, certainly you will go to your homework, you go to the past quizzes and the past lectures, right? So whatever you do, but you need to make sure you you want to look at those past quizzes. Okay, you look at the past quizzes, but I make those available, the solutions available until Thursday night. And after that, Friday, Saturday, Sunday, during those 3 days, you will not be able to see the solutions to the past quizzes. Okay, and the lectures, the past lectures will be available. Okay, they will be available throughout the semester. Okay, even after I'm on leave, I think you should still be able to see them. Do you guys have any questions? Questions from you? Let me close the door. The midterm or multiple choices, will there be? The midterm will all be multiple choices.
About how many questions will there be on the test?
How many questions? I haven't finished preparing them. Okay, probably around 30, between 30 to 40. So you have at least 1 minute per question. Any other questions? So what I would imagine is that you would, if I were you, I would review the materials, okay, some of the lectures. So the material covered will be from mathematical principles all the way up to Thursday last week, okay, arc cotangent. So any material that we cover this week that may be on the exam, I will let you know. Okay. Because I'm still in the process of preparing the questions on the exam. Okay. And today, since we have covered those other materials, and I'll leave you time for you to review. So I'm going to move forward. If you don't have any questions, but understand if you have any questions, please don't hesitate to ask me. Okay. So first of all, remember at the beginning of the semester, I said the theme of this semester is function. Okay, the theme of this semester is function, and we have reviewed all the 22 functions that's in this course. So I'm going to bring up all those questions, all those functions up there. Okay. So I made this thing. I don't want to type it again. So that's right here. Okay. We said that this entire semester about function. You guys have learned a lot of mathematical knowledge before, and all of those will fall into these. You will find a place in our context, right? So most important concept in here is a function, right? We talk about the making of the function from the basic function. So here I just enumerated these 22 basic functions. And from these functions, right? And then of course, what is a function? And we talk about a function is a rule, right? And this rule will assign each number, each element from the domain, exactly one element in the range, right? We are keeping our eyes on this definition, and we went over all of these different functions, which corresponds to different rules. Some rules are pretty simple, some rules are pretty complicated. For example, the last 8 functions we talk about, these rules, it require a stage set, it require understanding of ARD, right? So these are more complicated rules. The lesser complicated rules are like the exponential and logarithm functions. And these functions, the rules are, you also need to understand the relationship between them, which we spend a lot of time. Along the way, we mentioned the one-to-one function concept, increasing function, decreasing function, even function, odd function concept. So all of these will be addressed on the exam, on the midterm exam. Okay, throughout, through your homework and through the exercise, through the contents we covered on the, throughout the 7 weeks in the past. Now, with that behind us, right? And I also want to go back to talk about that. We mentioned that in mathematics, there are only 2 kinds of sentences. One is called statement, right? And the other one is if statement. Okay, in today's lecture, I wish to explain to you, right? And I introduce the if statement. When you are in computer science, when you're doing computer programming, you will find that in computer programming, you also just have these 2 kinds of statements, statement and if statement. And of course, the if statement in computer programming can be more complicated. They can be loops, they can be iterations, and they can be, but they all have some conditions. They're all conditional statement, like if statement. And they also have statement they call assignment, right? So the statement are the things we have discussed with the kind we spend a lot of time on is that these are descriptions of rules, descriptions of different rules, right? The basic 22 functions are basic 22 rules. For different rules, they have their own specific characteristics. Now, other statements such as any number times 1 stay the same, any number as 0 stay the same. These are also, those statements. They can be true or false, right? So that's the statement category. And the other one is called if statement, right? If you have never paid attention to the if statement and its application, and today I'm going to give you an overview about the if statement. Okay, so what is that? What are those if statements? Have you ever seen it? Surely you have seen them. Okay, so we're going to focus on the if statement. Okay, i.e., we're going to focus on the meaning. To me, understanding mathematics, understanding the meaning is paramount. It's very important, right? You guys understand my background, right? I'm not I'm not a genius in mathematics. I learned math the hard way, okay? And in time, because of my schooling and my teaching, right? And from those experiences, I have reflected much. So my lecture these days reflected my reflections on my learning and my teaching. Okay, so meaning, it's very important for you, especially you're not a math major, to understand the meaning, right? Because if you don't understand the meaning, you try to memorize it, and it's always a very, very frustrating process, and it's very, very difficult. Now, so we're going to focus on the meaning. So what is an if statement, right? You usually don't see these if statements, okay, because they are being shorthanded. They are in shorthand notation. But as we go through the thinking process to solve each question, we need to understand it is an if statement. For example, the first example I'm going to give you, okay? If I give you something like this, I say, solve for x, right? And here you're given something like 2x minus 1 equals to 3. Do you know what to do? I believe each one of you know what to do, right? I believe each one of you know what to do. Am I right? What do? You automatically do it, right? You do it automatically, right? But have you ever thought about its meaning? What's the meaning of it? In this kind of setting, it is actually set up for a if statement setting. The true meaning of this question, is saying, if 2 times an unknown number x minus 1 is 3. Okay, is represent equal sign. Okay, this basically says if 2 times a number minus 1 is 3, what could this number be? So that is an if statement. So this kind is an if statement. But in our textbook, in a lot of the textbook, it's being called what? It's being called equation. Equation. So equation itself is an if statement. In computer programming, you're not going to see equation. You're not going to have equation. You're only going to have if statement. You're going to have if statement. Okay, you're going to have if statement. All right, but anyway, without further ado, so the first kind is equation. So the equation is actually something we are familiar with. Okay, to me, it's very important for you to understand, because if you know the sentence, if you know the structure of a sentence, right? If you know what is the setting, you know the context, you understand the question, and then solving the question is just a piece of cake. That's what's going on most of the time. That's what's going on most of the time. All right. So if 2x minus 1 is 3, so this is saying if 2 times the number minus 1 is 3, okay, find all possible values for the unknown number. For the unknown number. Okay, so now as we talk about function, the theme of our class is a function, right? The function perspective. What is the function perspective? What is a function perspective? The function perspective is basically saying, okay, x is the input. I don't know what it is. Okay, and this input is going to be processed. How is it processed? And this is the rule. That's how it's being processed. It produces an output. And what is that output? The output is 3. Okay, so this is what that statement means. Okay, so knowing there's a function, it takes input. We know the output. So what is the input? Give me all possible inputs. So sometimes you have more than one solution, right? You have more than one input that corresponds to the same output, right? So this will be now consistent with what we talk about. All kind of techniques could be developed. Yes, you guys have learned a lot of those techniques. For example, you know what to do to solve this equation. That means you have certain techniques. But the fundamental of solving this question is that we need to be aware of that this is an if statement. This is an if statement. So this is one of the statements we're talking about. Statement, we spend a lot of time in the first 7 weeks about statements, right? Description of rules, right? Statements, description of rules, right? And the functions are description of rules. Each function is a description of rules. And next, we're talking about the if statement. If statement, if you see it from the function's perspective, sometimes it gives us a lot of insight. It doesn't mean you cannot use the rules you have learned before. Of course, you can learn that you can use the techniques and the tricks and whatever you have learned before, but you need to understand that the nature of the question. The nature of this question is that you're trying to find inputs. Okay, after a rule is applied to the input, it produces the output of your choice. The choice, of course, is 3. Okay, because we see this from a function's perspective, because I know you know how to solve it, I want to give you another perspective. Okay, the other perspective would be that 2x minus 1, we know that this is a function, right? A function will have a picture, right? A function has a picture. We have done all those pictures, right? Domain, range, x-intercept, y-intercept, and so on and so forth, right? We have done all of those. So now with this function, what it means, okay? What it means that we know the input, but we don't know the input, we know the output. We know the output is 3. We know the output is 3. What does that tell us, right? So with this function, we have a rule. We have a rule, right? This is the rule, right? You can see this rule is 2 times x. It's a combination of the basic functions, right? 2 times x minus a constant. But that's the making of the function. But now, since we know the output, we know the output is 3. we know the output is a vertical measurement, right? It's a vertical measurement. And the vertical measurement is what? The measurement is from the origin, measure up by 3 units. So we measure up by 3 units. So that function, so that 3 is a horizontal line. Horizontal line. That means the output, right? It's a vertical measurement. It's a vertical measurement. And this horizontal line 3, y equals to 3, across the line, across the rule we are given, it has a point of intersection. It has a point of intersection. Okay, it has a point of intersection. This point of intersection, we know that it's marked by input, output. Input we don't know. Do we know the output? Yes, we do. The output is 3. So our task here is to knowing the output to identify the input. So that's the nature of the question. That's the nature of the question from the function's perspective. From the function's perspective. Okay. And of course, I know you can solve this algebraically. That's not a problem. But introducing this perspective, okay, especially in this day and time, okay, technology is so, there's so much technologies at our fingertips. If you know how to manipulate these technologies to solve your question, especially it's easy to get graphs, right? If you can see the nature of the question, you can solve questions actually by using the technology properly. By using the technology properly, okay? In fact, a lot of the mathematical questions are solved by using some modern technologies, okay? But anyway, without further ado, right? You have solved it, right? So what have you found for x? For x over here? You add 1 on both sides, right? And divide by 2 on both sides. Of course, you're going to get x equals what? You're going to get x equals to 2. Okay, so this is the question, knowing the output, looking for input. You can see, right? When we did all of those questions, right? We plot points and so on and so forth. Sometimes we know the input, we're looking for output. Sometimes we know the output, we're looking for input. Are there any other kind of questions? The answer is no. No, absolutely not. Okay, so all the math questions can be classified into 2 categories in terms of if statement. Okay, for all of the if statement, it's all about knowing the output, we're looking for input. Okay, we know the output, we're looking for input. But then you say, what if I know the input and I want to find the output? And then you just, all you have to do is just plug in. We already know how to do that, right? You know the input, you want to find the output. That's all you need to do, right? You just plug in the rule. Plug in the rule. We have done a lot of that, right? So it's just these 2 kinds of questions that you're dealing with. But what makes your learning so difficult is because the different rules, right? The complicated different rules, which we spend much time on, right? And the other one is the necessary algebraic skills. It does need a lot of necessary algebraic skills. All right. But first of all, if you look back on your mathematical experience, you should see, you should put your questions on the different categories, like I have just classified for you. Okay, 2 kinds of statements, right? Statement or if statement. And all we do is apply mathematical principles in the appropriate places to resolve the issues, Okay, so that's the first example. That's the first example. Okay. So this today, even though we're covering if statement, you will see along the way, I will review some of the materials we have learned in the past because they are necessary. They are necessary. So this makes the first example, right? Something that you guys are very familiar with, right? You guys who came into this class, you already know a lot of mathematics. You already know a lot of mathematics. If you have any questions, say, oh, I have a question, Ms. Wang, I want to see what kind of question, how do I see this, right? Well, feel free to ask me. Feel free to ask me. I will help you to get started to see the questions you deal with from a slightly different perspective. Okay, now example number 2. Example number 2. Okay, now we've been focusing on these basic 1, right? We spend a lot of time on basic 1, but along the way, I assign a lot of homework to you, right? So now let's look at the if statement. Look at basic 4. Basic 4, right? Basic 4 says solve for x. Solve for x. What does that mean? What does that mean? Okay, so here we have a very specific, I'm going to pick up a question. Okay, I'm going to pick up a question here. I'm going to pick up a question for you. So the absolute value of an unknown number is equals to 3. Okay, I pick up a very simple one. Right? What does it mean? What is the function perspective? Some of you know the answer, some of you may have forgotten, right? But it's okay, it's fine. If you've forgotten, that's okay. If you've never seen this before, that's fine too. But when you study with me, you know that we have graphed this function, right? So the perspective of function is x is unknown. So, but this x is in the row of input. And the function in consideration is absolute value of x. So this is the rule, right? This is the rule. Absolute value of a number is the rule. It produces an output. And we know the output is 3. So once again, so I'm going to copy this sentence. I'm going to copy this sentence to see what I have changed, right? The only thing that has changed is the rule has changed. The rule has changed. The rule, instead of being 2x minus 1, now it's absolute value of x. If the absolute value of x is 3, then find all possible values. Do you see that a parallel relationship? Do you see that? It's an if statement. It's an if statement. Okay? And from function's perspective, from the perspective of function, right? And we know this picture very well, right? We spend time graphing it and we identify domain and range. You even have quizzes on it, right? So this function is, so let me just make some adjustment to put the picture in place, right? To put the picture in place. That's the picture. That's the whole rule. Okay, a rule determines the graph. Domain, range, everything determined. We have studied it. Okay, if you have any questions, go back to watch those lectures. And now it says, okay, if the output is 3, give me all the possible inputs. That's the question. If the output is 3, give me all the possible input. So since I know the output is 3, you can see that 3, that horizontal line, that the vertical difference, the vertical measurement, right? That's the output. It has 2 crossings with the curve. And our job Our job is to identify the inputs for these 2 points, right? For this point, the input is unknown, but we know the output is 3. And that point, I don't know the value, but the output is also 3. And of course, by this time, you guys already know the answer, right? So what are the answer? You will identify the input. So what are the inputs? The inputs can be identified by drawing this vertical lines, you have identified there's a -3 and +3, right? So the answer is that if, right? So if you make a complete sentence, right? Say, if the absolute value of x is 3, right? Find all possible values, then you would say x may be -3 or 3. Okay, or sometimes we write it this way. X is +3 or -3. Okay, so you can write it this way as answer, or you can write that way as answer. How do you read it? -3 or 3, because x can only assume one number at a time, right? All right, so that you can see that's the nature of this question. That's the nature of the question. It's an if statement in nature. Okay, it's an if statement in nature. Now, okay, any questions so far? All right, so I'm going to move forward, right? I'm going to give you some other questions that's related to it, right? And we fast forward, we're getting to the trigonometry. We're getting to trigonometry. In trigonometry, we know that was ARD, right? ARD. Take a question in trig 10A. Okay, I didn't give you homework questions yet, but you will eventually get to do some of those, right? But today's lecture is an overview on the if statement, right? So let's do example number 3. Okay, so questions of our interest is trig 10A. Trig 10A. Okay, I'm going to pick a question arbitrarily. Okay, and I want you to see how the knowledge we learned in the previous 7 weeks we have reviewed is going to be useful. I pick a question that's it's not terribly conventional, okay, but it's very common. Okay, it says cosine x equals to 1/4. And the title of this section, of course, is solve for x. Solve for x. Like always, right? Solve for x. Before we do it, right? Excuse me. Before we do it, do you need to worry about, is this cosine the restricted domain, the, whatever, or the constraint function, the constraint cosine? Your question should be answered as you should not worry about it. This is the cosine that's defined on the entire real number. Okay, that's something you don't have to worry about. Any sign, cosine, tangent, cotangent, and so on and so forth, if they're mentioned, they're referred to, some people address them as the original cosine, original sine, and so on and so forth. No question about it. Unless otherwise specified. Do we have any otherwise specified situation here? No, we don't. We don't have otherwise specified. There's no specifications about x, right? So this is addressing cosine. The cosine with domain of all real numbers. Okay, now meaning. What is the meaning? The meaning is if statement again. The meaning, right? Even though in mathematics we use these solve for, it's really if statement. If, okay, cosine, the rule of cosine apply to an unknown number x, and because cosine apply to x, the x must be an angle, right? Because cosine take angle input. So whatever x is going to be, whether it's degree, radian, it's going to be treated as an angle. If cosine x, if the ratio is a quarter, that is the if statement. Okay, so what is our task? Find all possible values for x. Same meaning, different rules. You follow me? And of course, the function's perspective is still the same. Cosine. It produces an output, and that output is a quarter. That's it. So our task, okay? We know that x is from where? The domain of cosine is all real numbers. So this will be from negative infinity to positive infinity. So this is where you're going to search for the solution. And your solution is going to be from the domain, and some of them will make the cosine ratio equals to a quarter. So how do we solve this question? Some of you might know, some of you might not know, some of you might have not even taken trigonometry. What do you do? What do you do? Well, we have worked out that cosine curve, didn't we? We have learned about arc cosine, right? So this is the moment we're using it. And you also understand this is actually, when we talk about ARD, this is from D to A. It's from D to A, not A to D, right? Because A to D, you typically have the angle already. Now we don't know the angle, so it's D to A, right? We know D to A. But we know every one of those ARD. Okay, we need to know the implication. Now, the visual. What is the visual? What is the visual, right? We know cosine curve, don't we? The cosine curve is at your fingertips. It's at our fingertips, right? Just you press the button, you get a cosine curve, right? Boom. Wait, did I do something? Oh, okay. Oh, never mind. That's why. Okay, cosine curve. And we know that cosine curve goes on and on in both directions forever and ever. What does it mean that the output is a quarter? Same thing, right? You will measure a quarter. That red line is a quarter. Horizontal is a horizontal line because that's measured a quarter higher. It's a vertical measurement from the origin, right? Remember, input is horizontal measurement, output is a vertical measurement. Remember that basic stuff? That is the basic stuff in application, right? We mentioned that students keep asking professor, what are you going to test us? And the professor will always say, well, I'm going to test you the basic stuff. These are the basic stuff. These are the basic stuff. The basic stuff, will they ever change? They will never, ever change. They will never, ever change. Okay? So now we have a quarter graphed. So what are we looking for? We're looking for input. We're looking for input. The input such that the output is a quarter. So now we got all of these crossings. All of these crossings, they have the same output quarter, right? Every point has an input, output, input, output. We know the output already. All of them have the same output a quarter, right? How do I know? Of course we know, because they're all on the same horizontal line. So this point, I don't know the input, but I know the output is a quarter. And this point is same. That point is same. So this point, I don't know the input, but I know the output is a quarter. Do you guys see that? I don't know the input, but I know the output is a quarter. This point, I don't know the input, I know the output is a quarter. Do you guys follow me? And this point, we don't know the input, we know the output is a quarter. And so on and so forth. This goes on forever. How many solutions could there be? We're looking for the inputs, right? So what are the inputs? The inputs will be here. If you draw a vertical line here, you're going to get an input here, input here, input here, input here. So these stars are what we're looking for. You follow me? We're looking for these stars. For this star, the input is no, and the output is a quarter. This star, quarter. The output is a quarter, right? So the stars are what we're looking for. How many do we have? We have an infinite. We have an infinite of them. So from this picture, we can recognize that there are infinite number of solutions, right? There are infinite number of solutions. A lot. But how do we find them? You can't tell the professor, hey, this is the picture, go find it yourself. But then you're not going to get the points, right? You're not getting a lot of points. So how are you going to get those points? Well, we're going to start from simple, right? We're going to start from simple because there are some patterns among these points. There's some patterns among these points, right? Now, to identify the simplest point, okay, so I'm going to clean up a little bit. Could I clean up a little bit, right? Maybe not yet, okay? I'll try to keep as long as possible. Remember in the last weeks, I'm asking you guys to identify, this point and that point, right? Those are very important practice. Those are very important practice. For example, I'm asking you to identify this highest point here and the lowest point over there. Because this point is between the highest and the lowest, right? And you see the periodic, the function is periodic. So this piece and that piece, right? Between these two pieces, between this heart and the next heart, and the difference is 2 pi, right? From between this piece and that piece, because this point and next point and that difference is also 2 pi. Yes, do you guys see that? Right? And if you keep going, you can see between these two places, that difference is 2 pi. That difference is 2 pi. And from that point to that point, that difference, the input difference is 2 pi. So as we get closer and closer and observing these, we found lots of patterns. So it's very important for us to identify these 2 points, because if I can identify this point and next point, I can get to the rest of them. But how do you identify these 2 points? Well, I'm going to bring in the unit circle. I'm going to bring in the unit circle. Okay. So now, right? Next, I'm going to find my unit circle, that my dear unit circle. Okay. Or the just rectangular system, right? My rectangular, my definition, ARD, right? From ARD's perspective, I can work with this guy or I can work with this guy. This guy is cleaner. This guy is cleaner. Okay, it has a standard position. I know how to measure points. So what I know, what do I know? That's what I know. I know the cosine ratio is a quarter. I know the cosine ratio is a quarter. Okay, so now if I know the cosine ratio is a quarter, I know there are many, many angles corresponds to it, and we know that for sure, right? So if I measure the angles, when I measure the angles, I always measure from the standard position. That's the A in ARD. So I don't know the angle, but I know the terminal is going to be ARD. Therefore, if I measure here, right? Cosine is X over R. X over R, right? We pick a point. Remember in the definition, what was said? In the definition, right? In the definition, we select a point. We select a point arbitrarily on the terminal sides of the angle, right? And that point is XY. XY, right? So I'm going to use a color tone that we are familiar with. Whoops. I want that to be erased. Okay. I want the red. Okay. The X coordinate and the Y coordinate. The Y is blue. Corresponds to the red and blue on the unit circle. Okay. Still refer to what we have done before. Okay. Refer to what we've done before. So on this term, on this side, the ratio is 1/4. So we know the D, right? We know the D. So when I mark this, you guys need this skill in Calc 2, okay? When we mark this and we know that this is Y, and that is X. Okay, remember we talk about special angles are in service to the 3 pillar, right? I have a lot of students I have taught before. They came to my classes, they can deal with all the special angles or most of them. But if I throw in a non-special angle, they don't know what to do. What does that tell us? That tells us the student didn't really understand the topics thoroughly. Okay, this is also the reason I chose a non-special angle, right? So you have, so what does that tell you? This side is 1, and what's the hypotenuse? The hypotenuse is going to be what? It's 4. That's what it tells you. Cosine ratio is 1/4. X is 1, 4 is the hypotenuse. If you want to find the blue, you can, but we don't need to do that here. We don't need to do that here. So we have identified one terminal. We have identified one terminal, okay? Any angle terminates on the green, and that's going to have a cosine of those angles ratio of 1/4. And the next question is, do we have another terminal? And indeed, we do. We do have another terminal. Another terminal is going to be here. Okay. It also has a blue, But this, any angle terminates in the lighter green, this green will also have a cosine ratio of 1/4. You follow me? So that's the dr. We're getting to A. We're getting to A. Okay, we're getting to A. Now, do we have other terminals that will produce cosine of angle terminating all those terminals that will produce 1/4? No more. We have found 2. That's it. No more, because in other ones, the cosine is going to be negative, right? Cosine are positive in the first quadrant and the fourth quadrant, right? Now, so with that said and done, and the next question is, it is not a special angle, right? It is not a special angle. So what is this angle? Right? And what? Because you just have to identify one of the angles, right? This angle, I'm going to call it theta. Okay, I'm going to call that angle, hold on, the dean is calling me. Yes, Marlo? I'm teaching right now. Is this urgent? Okay, later. Okay. Bye. Bye. All right. Sorry about that. You can see this angle. What is this angle? This angle can be represented by arc cosine. We have learned that arc cosine produces angles between 0 to pi, right? Remember that? That's the range of arc cosine. So this theta angle that terminates in the first quadrant is going to be the theta angle. Do I need to care what theta is exactly? You don't need to. If in the future you have a secretary, your secretary can get that number for you. Okay? Yes? So how about the other one? The other one, how do you measure the other one? You can measure this way, right? But you can also measure clockwise. So this angle is going to be what? It's actually going to be negative theta. So once you know theta, you will know negative theta. If you punch in the calculator arc cosine 1/4, it's going to give you the angle. But do you have to know that angle? You don't need to. Your professor, especially in the math department, they are super happy to see this guy. They don't want to deal with that decimal number. They don't want to deal with it. Just give them this expression. They will give you all the points that deserving for that step. Do you guys follow me? Save you the time to type in the calculator. Okay. Now, so we have identified all the terminals, right? We have identified all the terminals, and we know these 2 angles, right? Doesn't matter, right? You can get more. You can get them in different ways. They're not unique, but knowing these 2 will be enough. So I want you to write down these theta and negative theta. Did you write down the theta and negative theta? Because we're going to go back to the picture we just came from. Okay, that theta, negative theta, what are they? Okay, the theta we're talking about here, the first one, if you understood the graph we did before, this is the theta. I use orange color, refer to the arc length, okay? And that's the theta, okay? That's the theta. And the height, okay, I'm gonna use the blue height. This point, okay, is the theta. And that's the quarter. The orange color refer to the arc length at the beginning we're graphing, cosine, the sine, tangent, whatever. And the blue refer to the blue numbers you see on the unit circle, that they have the same, they are the same category of numbers, which is for, oh, I'm sorry, it's a red number, my bad. What red number? Did I confuse anybody? Cosine is red. Okay, my bad, it's a red number, okay? Red number, forgive me, it's a red number, 1/4, because this is a cosine curve, my bad. And what is the negative theta? The negative theta is right here. Still measured from the from the point of reference, the origin, okay? And that point, I should use red. My apologies, okay, red. And that should be red. Did I confuse you guys terribly? I will do it all over again for you. This is a cosine. The cosine is a red number, right? This red number refers to the red I drew earlier. Is everybody with me? So that red. So that point, this point, okay, the orange is negative theta, and the red number, this is a cosine curve, is 1/4. Do you guys follow me? So that's the quarter. That's the quarter. The red number. Okay. So far, so good. We did draw the red in the picture before, right? Once we found these 2 points, voila. We just add a 2 pi to add a 2k pi, we get the rest of them. We add a 2k pi, we get the rest of them, because, right? If you take this point, you add a 2 pi. If you add a 2 pi, you get there. You subtract 2 pi, you get there, right? So you can keep going in both directions. And this one, you add 2 pi, you get there. Subtract 2 pi, you get there. So all the points are covered. So finally, what would be the solution to this question? If cosine x equals to 1/4, what are all the possible answers? Well, all the possible answers would be, okay, so let me write it down in a somewhat compact form, right? 2 of them. One is theta plus 2k pi, or negative theta plus 2k pi. And what is k? K is any integer. K is any integer. Okay. Another form you can write this answer is that you can write it as, x equals to plus minus theta plus 2k pi. If you like to write plus minus 2k pi, that's not wrong, but it's not necessary. Okay, I would just use plus, because k itself can be positive or negative integers. So this will be that compact form. And of course, you should specify what theta is, right? You should specify theta is arc cosine 1/4. Okay, and k being any integer. So that would be the solution. That would be the solution. Either form is okay. Either form is okay. There's really not a preference. And are the form of solution unique? Of course not. Of course not. They're not unique. Okay, you have other forms, but these forms will be the the simplest usually considered. Do you guys have any questions? Do you see how that ARD come to our rescue, right? In the case that they're not special angles, they're not special angles. In fact, the reason we are given those special angles is asking us to practice this process for when it is not special. It's not special angles, right? But a lot of our students turn out, they have learned all these tricks, right? I don't know where they learn them. It's great to know those tricks. I have no problem with them. But you have to be able to apply ARD to any situation, special or non-special. Special or non-special. This is why we said that the, ARD is a pillar of trigonometry, not the special angles. Okay, if you only know the special angles, you don't know ARD, it's like a building without a foundation. It's like a building without a foundation. Okay, you're building something on the sand. You're building on something on the sand. Okay, so shall we take a break? We'll come back to this. We'll come back to this. Okay, so I'm going to give you like until 12:25. Okay, back at 12:25. And I'll see you soon. For sure, the department is trying to make the best arrangement to cover my classes. And I will do my best to talk to the next instructors, because I would hope that I can talk to the next instructors before I'm on leave. And you will be in good hand. The dean takes it very seriously. So on his book, you guys' best interest is at his heart. It's, he's always aware of that. So be assured that you will be taken care of. Okay. All right. So we are back. Right. Do you guys have any questions? Right. So this is you can see the question, right? The nature of the questions related to the rules and so on and so forth. How important it is for us to understand those basic functions. Okay, but those basic functions. Okay, so let me give you another example. Okay, these examples will be related to exponential functions and logarithm functions. Okay. So here I'm going across the notes, right? I'm getting into the sections of exponential and logarithm, right? So this one is on EXP1. So this is probably example number 4. Is this example number 4? Yeah, that's example number 3, right? So let's look at example number 4. Example number 4, I'm going to pick a question which is on EXP1A, right? EXP1A. So here we have a question says e to the power x, whoops, e to the power x equals to 5. What does that mean? What does that mean? Right? Of course, I know you guys know how to solve this one, right? You've been taught a variety of ways of solving this, right? But what is the function perspective? What is the function perspective? The function perspective will still be that you have an input, right? And this input is apply this rule, which is e to the power x. It produces output, and we want the output to be 5. So we're looking for input, right? So once again, this is an if statement. So if, right, e to the power of an unknown number is 5, right? Find all possible values for x. And in this case, there'll be some interesting insight that we can see, right? For example, we have learned e to the power x. We know the function is 1-to-1, increasing, have all these nice properties. Domain, right? Domain range, e to the power x is always positive, right? There you go. So you can apply that. Once you apply that increasing function property, then you know you only have one solution. The solution you have will be unique. You're not going to have two solutions like, you know, in some other cases, right? With that said and done, from the graph, we understand, we know the graph, right? So how does the graph look like? We are very familiar with the graph. We have done it, right? We plotted points. We did, right? Remember with the points we plotted, right? 2 to the power x, 3 to the power x, 10 to the power x, e to the power x, and all of that stuff we have done. Will give us an impression. Okay, we understand this curve. We know we can plot many points on it, right? So let me make it just a little bit more adjustment here. E to the power x. We know the output equals to 5. We draw 5, right? Red. As we anticipated, this is a 1-to-1 function. This is a 1-to-1 function, right? And it has exactly one solution for the output 5. So we know we know the output. The output is 5. And we're looking for the input. So what will be the input? Okay, we have algebraic method to find it, and x should equals to ln 5. Okay, x should equals to ln 5. Okay, we'll get to these techniques. We'll get to these techniques, right? There are different techniques. The different techniques using definition and doing this and that. You guys have learned a bunch of those, right? But this is the function perspective. This is the function perspective. All right. So let's give you another example. Example number 5. Okay, so I'm going to take a logarithm situation. The logarithm situation, I'm going to have this example, right? And once again, is solve for x, right? So the question at hand is that common, it's a log x. Maybe I should use ln. Ln x equals to -2. I'm just making up an example, okay? I'm just making something up, okay? Similar to something that you would see at log 15a, okay? So for more exercise, refer to log 15a, okay? The rest of the semester, you guys will get to it, right? But today is kind of an overview, okay, about the application, okay, in the context of if statement. So what does this mean? What does this mean? This means, right? Once again, we know input and the rule of ln x, right? It's applied to the input, produces an output, and we want the output to be -2. Okay, we want the output to be -2. So find all possible input. find all possible input, right? So once again, it's an if statement. It means that if ln of an unknown number is -2, okay? And we want to find all possible values for x. You see, it's the same framework. It's the same framework. It just the rules are different, right? So when we look at ln x, what do we need to think about? Domain, range, right? Do you guys still know the domain and range for ln x? Do you guys still know the domain and range for ln x? You should not be surprised. I'm going to test you about these things, right? And you're going to be using these things in calculus classes. So what is ln x? You get the picture. Now, these days, you get those pictures at your fingertips, right? Very easy. Right? We get a picture. We get a picture. And the output is -2. The output is -2. There we go. We have a -2. There's a crossing. Boom. It crosses a place, right? And you need to identify points. You need to identify the input. So we know that this input is unknown. We don't know the input, but we know the output is -2. By this time, you actually already know the answer. You've done all the graphings and stuff, right? So what is the answer? Could you guys tell me what the answer? How many answers should we expect? We should expect only one answer, right? Because ln x is an increasing function. It's a one-to-one function, right? So all that knowledge we have learned about these functions will help us to determine, right? So in the end, of course, we get x equals to e to the power of what? -2. Okay, e to the power -2, 175%. Okay, so this is the if statement. This is the if statement. Okay, one category of if statement. There's another category of if statement. Okay, so the first category of if statement, right, we just talked about, right? Where's that if statement? Right here. It's an equation. Equation. We have seen all of these examples. I've seen all of these examples, right? And the second category is inequalities. Inequalities. What are inequalities? What are inequalities? Right, so I'm going to put this, I'm going to put inequalities on the top. Okay, I'm going to put inequalities on the top. The second category, inequalities. There are if statements. There are if statements. Okay, but some of us may have questions about what are inequalities. Okay, in these inequalities, you are going to see you're going to see these symbols. You're going to see these symbols. Okay, one of the symbols is greater than. Okay, let me add another column. Okay, so this one has a meaning. Greater than. And the next category is less than. Okay, and the other one is greater than or equal to. Greater than or equal to. And the next category will be less than or equal to. okay? And the other one is not equal to. Not equal to. But these is also the making of if statement. Okay, you will see these symbols. You will also see these symbols in programming. Okay, some programming already adopt these symbols. Some programming you may have to use other stuff, but they're all very similar. Okay, so examples. Examples, okay? The first example I like to talk about is about the absolute value type, okay? Tomorrow, we're gonna spend some more time on the absolute value, but today as an overview, I'll just use some examples, okay? I'm gonna use two examples here. One is basic 5, okay? Basic 5. Basic 5, okay? For basic 5, suppose the statement says, solve for x. Solve for x again, right? Pick a question here. The absolute value of x is less than 3. What is it? What is it? Well, this is basically say, if we take absolute value, the rule of absolute value apply to an unknown number, and the output is less than 3. Okay. Find all possible inputs. Find all possible values for x. For x. That's what it means. That's what it means. Okay, and the function perspective. Okay, the function perspective is that input is unknown. Output, we take absolute value of the input, whatever it is, produces output. And the output we want it to be less than 3. We want the output to be less than 3. Okay. We have studied absolute value of x extensively, right? We plotted points, we identified domain and range. There's a quiz on it. Those contents are basic, very important basic facts. You should not be surprised. I'm going to be testing you guys on that. Okay, there were already quizzes on it, right? There were already quizzes on it. So with that said and done, so let's look at the graph. This is the second, third time we're looking at the graph today, right? Less than 3. We want the output to be less than 3. Less than 3. What kind of concept is that? Less than 3. Right? So what is 3? So it's not 3, but less than 3. Right? So I'm going to draw a 3. But this time is less than 3. So I'm going to use a broken line. Let me use a broken line, right? So the output is basically the vertical concept, right? The output is a vertical concept. So we want them to be less than 3. All these are the output. All these are output. They're less than 3. And that point is exactly 3, right? So if we're sitting on the point, say sitting on the crossing, that's exactly 3. Those input are not solutions. So where do we find the solutions for the inputs? The solution would be over here. Okay, each one of the input between -3 to +3 exclusive, not including -3 and +3, and their output will all be less than 3. So our solutions will be the bold-faced green, not including the endpoints. Do you guys follow me? So how do we represent those? Right? How do we represent those? So the solution would be -3 less than x less than +3. So all of those numbers. Do you guys follow me? That's the picture in relationship with our questions. If the output is known, right? So how do you read the input output, right? The input is always horizontal measurement from the same point of reference. The vertical is always vertical. The output is always vertical. Okay, that's the output. Once you master these principles, it's just a matter of applying them to different rules, Any questions so far? Right? You guys have any questions? Okay. And of course, you guys understand this, right? You guys understand this. This is just like, let me draw this line better, right? So make it red, thick, right? So that piece, and we put a circle dots on it. We're gonna put a circle the dots, circle. There's another point, 3, 0, right? You guys are pretty familiar with that picture. Sometimes you only see the line. Sometimes you just work on the number line, right? You guys, some of you have been taught that way. But if you put them all in the function's perspective, that's what it is. That's what it is, right? So algebraically, how do you solve this inequality? Just 2 steps, right? 2 steps. But we want you to vision and understand, right? So if you're solving this inequality, your solution is just like that, 2 steps. Really, that's all you need to write. But should you be having this picture in your head? Yes, that'll be better. That'll be better. This added understanding. Then you say, what's the use of understanding this? Why do I need to understand this? Well, there's a lot of benefit about it. There's a lot of benefit about it. It broadens our thoughts, broadens our perspectives. And as a broadened perspective and a broadened thoughts, right? It bounds to help us somehow, somewhere down the road. Okay, so we see the consistency. The next piece I want to go over with you is basic. It's still under the inequalities. Okay, still under the inequalities. So this makes the example number 2. No, 3. Is that 3? I think it's 2. Wait. So this will make it example number 1. No, this is going to be example number 2. Example number 2, however, okay, it says solve for x, right? Where we have the absolute value of x is greater than 3. Greater than 3. If we understand everything we've done earlier, right? Everything we've done earlier, right? It's going to be, everything is, let me bring this up. You can see the change, right? The change is just because the output tells us different. We want output to be larger than 3, right? So this is going to be greater than 3. Greater than 3. Find all possible values. So we get this. So now these lines will not be relevant. Right? It's going to be the outside. You guys understand, right? It's going to be the outside. So the solution will be outside. Okay, so the solution will be outside. Okay, so let me just quickly put in there. The solution is outside. Okay, let me make some adjustments so that it could look better. Thick. Thick. I'm gonna make this -8, +8. And the next one, that should be thicker, right? Make it thicker. Right? Is this fitting to some of the things you have learned before? And the solution, of course, in this case, if this is larger than 3, the solution would be what? Will be x less than -3, which describe this piece, or x is larger than 3. Right? So each describe their individual pieces, and that piece describe that part, and that piece describe that part, and they are separated. They are separated, so we connect them by or. Connect them by or. The logic is that if x is less than -3, the absolute value will be greater than 3. If x is larger than 3, the absolute value will also be greater than 3. So we have 2 intervals with that solution. And you guys need to learn how to use inequality sign, okay, which I think, which I see has been lacking in our students, okay? So that's an overview, okay? Now let's get to some trick questions, okay? Let's get to some trick questions. Trigonometry. Okay, so this one I pick is going to be trig 12A. Okay, trig 12A. So this overview. Example number 3. Okay, trig 12A. And once again, we solve the identity. Okay, I tweaked the question trig 12A a little bit. Okay, solve for x. Okay, solve for x. In trig 12A, there's a specified interval, but we're going to be broader than that. We remove that constraint. Okay, so we're going to add that constraint. Without that constraint, we're going to see both, right? So this is the question. Sine of x is larger than half. Larger than half. How do we solve it? These are the typical questions, okay? You will encounter in calculus classes. You will, I assure you. You might, if you think, oh, is this sign the sign we know of? The original sign or whatever? Or this the sign with restrictions? You don't need to worry. This is the sign that we refer to as the sign with all real numbers as the domain. So this question is not exactly trig 12A. Okay, so I'm going to put it this way, okay? For more questions, go there. Okay. How do we solve this inequality? How do we find the solutions? Algebraically, how much you can manipulate? Very little, very little. Could I take an arc sine inverse on both sides? The answer is absolutely not. Absolutely not. Even if you do, you're not going to get very far. You're not going to go very far. Okay. So we're not going to talk about those pitfalls and mistakes at this point, because we're addressing this. We have this overview about the if statement and its meaning in mathematics, right? Apparently, this is an if statement. This is an if statement. Okay. This if statement basically says, okay, I don't know the input, but I know the input when we apply the rule of sine. We know the rule of sine is involved the stage, right? The ARD and so on and so forth, right? And it produces output. And we want the output to be larger than half. We want the output to be larger than half. So give me all possible answers for it. Find all possible solutions. So where do you find all the possible solutions? They are scattered all over the number lines. Okay, they're scattered all over the number line. So where do we find it? Right? So this is the time you get to see, knowing the sine curve in its details is essential. One perspective, right? One of the function perspective is that this is the sine curve. Okay, so I'm going to just give you enough of the curve. Okay. Larger than half, right? We know that this sine curve, we know how to read this curve, right? Do we know how to read the curve, right? The orange, the arc length, and the sine value is the blue number, right? It's the blue number. Yes, the blue number. So we want those blue numbers to be larger than half, larger than half. And of course, we also refer to, there's a unit circle to it, right? Where's our unit circle? Where's our unit circle? Right here. I'm going to take these with us, right? Because this is the stage set. This is the stage set. If you look at the unit circle, we want sine values, the terminal to be between, the terminal has to be between, let me remove that with 2 purple, right? You look at the blue numbers, look at the blue numbers, right? Half. But we want to be larger than half. Where do we find terminals whose sine ratio is going to be larger than half? Where do we find them? They are going to be measured from the standard position. They are going to be over in this piece, right? In this piece, every blue number, those special blue number or non-special blue number, they're going to be larger than half, right? So we have an infinite number of solutions, and we need to identify all of them. You follow me? So that's the nature of the question. Okay, so that's the piece. From the curve, larger than half. So I'm going to draw the half, right? I'm going to draw the half. What are larger than half? This piece is larger than half. That piece is larger than half. That piece is larger than half. We have many such pieces, don't we? We have many such pieces, right? So where do we find our solutions? Our solutions will be, there's a little piece here. There's a little piece over here. Okay, and there's a little piece over here. How many pieces do we have? How many pieces of this kind do we have? Infinite. Can you give me solutions to those infinite pieces? I'm sure you can eventually, okay? If this is the first time you see such a question, that's the nature of the question. We're just talking about that's the question. That's the question. How do we resolve these questions? How do we find solutions to these questions? ARD, right? In particular, this is actually from D to A, from D to A. Okay, because we know the definition, right? We know the ratio needs to be larger than half. So the key issue becomes what? Becomes to identify these 2 points. Because once you identify these 2 points has input, output, and these 2 inputs will be identified, right? So we will be identified the input star, output star. If I can identify this input, and then that'll be, if I add a 2 pi, I'll get to here. If I can get this point, I add a 2 pi, I get to the next one. I subtract 2 pi, I get here, subtract 2 pi, I get there. Do you guys see that? So it all depends on if I can get these 2 stars. Because there's a pattern to find the rest of them. Do you guys see that? Right? Because from here, right, you just add a 2 pi, you get here. From there, you add a 2 pi, you get there by adding 2 pi. I can get over here by subtracting 2 pi. Getting here by subtracting 2 pi. So adding 2k pi will ensure I get to all of them, right? We get to all of them. So the essentials is to get to these 2 points. Do these 2 points. What are these 2 points corresponds to? What are these 2 points corresponds to? They correspond to that fence shape I just showed you, right? So let me clear that. So these are the inputs. Okay, so let me just make it smaller. Okay, the inputs. Do you guys follow me? I'm sorry, today I talk too much, okay? Because I expect you guys to come to see these lectures over and over again, okay? Today's an overview. I think your future materials, whether I'm here or not, I hope these lectures is something you can come back to, okay? Now, so these 2 inputs, right? So we know we try to identify this interval. This interval, okay? And there's a star input here, and there's a star input there, okay? And the first star input has something to do with that terminal. The second star has something to do with the next terminal. So that's their relationship. So that's why it's so important. That's why we, in the past several weeks, right? We do the graph, we mark the points, we go back and forth between these different colors. Why do you think we do that for? For fun? That's part of it. That's building connections, because I knew we were going to need that connection for the future. Okay, so now let's see how is that related to it, right? Well, we know this is half, right? We know this ratio is half. I'm going to put the blue here. The blue half. That's half. That blue is half. That blue is half. That blue is half. And that blue is half. And we got the terminal. So what is the first star? The first star is, you should know it, right? It's pi over 6. I'm going to write in the color of orange, right? Good thing is that our star is in orange. So this is a pi over 6. And this other star is 5 pi over 6. You guys see that? That's how they're related. That's how they're related. Half, 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 pi over 6, 5 pi over 6. Once you get those, right, that's all the terminals you have, right? You can identify this green, this interval, the input. So first interval would be the solution, right? The solution would be x, the input angle is between pi over 6 to 5 pi over 6. Okay, so let me write it down. Could you guys have these in your notes? Because once I start writing it down using the software, it's gonna mess up. Any questions from anybody? All right. Okay. So next, so how do I describe? Okay, how do I describe this interval? So the input, okay, is going to be between pi over 6 less than x less than 5 pi over 6. This is the description of that green, that piece of green. You follow me? Exclusive does not include pi over 6, does not include 5 pi over 6. How about the other piece? Can you guys describe the other piece of green? Can you describe the other piece of green? Could you? I'm going to give you a second to see if you guys really understand what I'm talking about. Yeah? Do you understand what I'm talking about? Can you describe this other green? Don't worry about the rest. Don't worry about the general consideration. Can you describe the other green? What should that be? It should be this guy. This adding 2 pi, right? Does everybody follow me? Yeah? If you understand that, can you understand the other? Can you get the other green, the other piece of green? right? What would that be? That piece will be minus, right? Minus 2 pi. Okay? And so on and so forth. I would say this is not easy. This is not easy. Okay, but this will lead you up to calculus. This will lead you up to calculus. All right. So the next piece. Okay. So I'm going to add this plus 2 pi plus 2 pi I run into some programming problems. Maybe they cannot do the. You cannot do the. Oh, here, my bad. See, the program has to be sound. Okay. Clear all that other stuff. Is everybody with me? Do you guys understand what I'm doing here? Okay, so this is what the if statement leads to. And this is what our foundation can help us, the foundation we built in the past weeks can lead us to. Okay, to be able to handle situations of this kind, right? So I'm not going to draw this piece. You got the ideas. Okay. Next is summarize, because we have only 3 minutes left before the end of the class today. And this afternoon I will be seeing my surgeon. So I will know for sure the date of surgery and the date I will be out. That's why the dean was calling me for, and the department is trying to make the best arrangement possible for the students that I will not be able to attend to. And so this is the overview today. So today's overview is mainly about these two, introducing the if statement, equation inequality, right? And for the rest, I will give you a review. Okay, so what in the process you review for this week, whenever you have any question, please don't hesitate to ask me. Okay, you can ask me anytime. Don't worry that I will only be, seeing doctors for so many hours, but I will be back. And if you have any questions, feel free to use a pronto and text me. And of course, once I go into surgery and I will not be available for the period of surgery days, and I will not be available maybe for the rest of the semester as the doctors has instructed, but surely, and I will be back alive. And next semester, in the spring semester, I hope I will see you guys on campus. And next semester, I will still be teaching Math 180. I will have 2 sessions on Math 180. One is online and one's in person. Okay. And if any one of you who made it to calculus class and you have questions about Math 180 stuff, or even you have a question about Math 190 stuff, I will be very happy to answer your questions. And just don't hesitate to reach out to me if you ever have such a need. Okay. And I think that's all for today. And tomorrow we will continue the study. I still have a week to be with you guys. Okay, I still have a week to be with you guys. And I'm looking forward to the next time. Okay.
Thank you very much, Professor.
Thank
See
you
you
guys. I'll see you guys tomorrow.
Thanks for the lecture, Professor.
Of course, anytime. I will miss you guys terribly.
Thank you, Professor.
Let me know of any questions, okay? Thank you. Have a great day.